Hello everyone, welcome back to the day 11 of Advent of Cyber 2024 of TryHackMe. So continuing with the series, we have reached the day 11 of Wi-Fi attacks. Before we continue, I would like to go up to the top of the screen and click on Start Attack Box as we'll be requiring this today. So my screen has become into half and now let's continue with the story. The story. The much awaited sock mass of Werewolf Town is just away. Glitch, the unsung hero, is closing all the doors of Mayor Malware's malicious intentions one by one. However, there is still much more to do. McSkitty took a thoughtful breath. Mayor can still find his way in. Glitch smiles confidently. I think I know the last technique he relies on to get into the network. Mixed Kitty stands up from her chair and a surge of excitement. Let me guess, it's a notorious way to get into a network. A Wi Fi attack? Glitch nods decisively. Exactly. Let's be one step ahead of the mayor. So coming down, we'll be requiring to log into an SSH session and all. Let's just go forward. When that comes up, we'll continue with that. What is Wi-Fi? So now MixKitty and Glitch have planned to do some Wi-Fi attacks. So before we do some Wi-Fi attacks, we need to understand what exactly Wi-Fi is. So Wi-Fi is basically nothing but an unguided medium of communicating to the internet. So you might have seen the Ethernet cables or the coaxial cables or the fiber optic cables, right, which is running down from your home or office to some place in which is there in the near the side of the road where the public network is connected to. So those are guided mediums. So what is Wi-Fi is basically an unguided medium, which is basically nothing but using waves and frequencies and all those things to communicate to that router which is present in the organization. It's nothing but an wireless medium to connect there. So fundamental aspects of a Wi-Fi would be to have an SSID in it. So SSID is basically a unique identification name given to the router's access point for us as a client to connect to it. And then there's going to be pre-shared key, which is also a password in the lame term, which will be that unique password which is given for you to connect to that Wi-Fi network. So if you typically look at your Windows operating system under the Wi-Fi section, you can see something similar to this. So they have given you an example of SSID called OK443S, which is the name for that Wi-Fi, and pre-shared security key, which is the password for it. So where you enter the password and then get connected to that Wi-Fi. So you get connected to that frequency. So Wi-Fi is like a doorway to the internet without any physical medium to connect your device to the router or the access point and then communicate to the internet. So what is the role of a Wi-Fi in an organization? So in an organization that could be PlayStations and desktops be located there, right? So there could be physical desktops connected. Now that is easily connected to the Ethernet cable, or if they are running down Ethernet cables through the walls and through the routers and switches, it's possible. But if you're carrying a laptop or if you're carrying a mobile device, now it's practically not possible to provide Ethernet cables and other mediums of communicating or connecting to your device to the router or the network of the organization. So it's rather easier for an organization to provide a Wi-Fi access to personal laptops and mobile phones or any other devices which require internet access or the organization's network. So it's easier to provide a Wi-Fi access. So organizations build up a Wi-Fi network in their infrastructure or the building. So now having a Wi-Fi in an organization gives us a potential threat because Wi-Fi networks or the signals are also accessible to anyone outside the building. If the signal strength is that good, it's also accessible there. So if it is not configured in the right manner, anyone in the public could also access the organization's network. So if you're into the Wi-Fi network, it's same like being connected through the Ethernet cable. You all be under the same network of the organization. So it's very critical role for a person or a system administrator or the network administrator to configure the wireless network in your organization. So it's very it should be really secure. And coming about if it is unsecure or even if it's secure, what are the ways that we can, as the attacker, can possibly break a Wi-Fi or get access to a Wi-Fi, or what are the attack possibilities for a wireless access point? There are multiple ways that how an attacker would do, but there are descriptions given here for the mainly four most popular and most actively exploited ways of compromising an Wi-Fi signal. Which one is first one is the evil twin attack. So evil twin attack is nothing but trying to have a similar name of an SSID. For example, to demonstrate how this would look like. Now, imagine you have your home or organization's Wi-Fi network to be this blue colored ink, which I will be showing here, which is named as, let's say, some good name which would work like network 1. So I'll say that organization has a name called as network 1. I did an error with the spelling, so I'll say network 1. Okay, that's your organization's Wi-Fi access point which is allocated to you. Now I, as an attacker, would try to replicate to have such similar names, but not the exact name, but a similar name to the one which is network 1, such in such a way that it looks similar in a glance through of an eye. So I will have my rogue network set up as something like network 1 but with two e's there. So now, just as one glance, you'd be like, okay, that's network. Okay, network 1 itself. So you might try to think that these are same networks and then try to log into that. Now, just you will not log in directly to that. If you are, for example, every time you are in your house or in your office, you don't enter the password to log in, right? So it's like it has saved in the login credentials and it is directly connecting to the network if you have told it to automatically connect to open networks or open to networks. So what it is going to do is, I, as an attacker, will send an deauthentication request to all the systems which is present in the network. If not all the systems, at least the targets, my targets computer on which network they should be deauthenticated to, or my target's or computer telling to get deauthenticated from the network. So once a person gets deauthenticated from the network, they'll realize that and they will click on the network which will say network 1, which is the malicious one, not the original one. Because what I'm going to do is, as an evil twin attack, I'm going to make sure that my network strength is more than the one which the genuine network will, is having a strength of. So it's going to try to mimic this network's name by having a double E here, and then it's going to also have a better strength of Wi-Fi signal than this one. So by automatically you will try to connect to my network. So it's one of the way how you're going to be performing this. For performing this such network attacks, we usually when we go for red team activities, we use something called as the Wi-Fi pineapple. So it's a device which has all these features built in it. It's from an organization called as HackFi, which do produce such hacking tools and methods for penetration testers and red teamers for performing their activities. So we use that tools. Now, coming back to our next type of attack, which is rogue access point. So it could be in an organization or even an open public place like a coffee place where everyone would go and hang out. I could have a open Wi-Fi network just enabled there. I, as an attacker, will just keep a Wi-Fi network which is open for anyone to connect. Now, if your system is configured to connecting to open networks, it's going to connect to it, and I, as an attacker, can do anything like trying to intercept whatever messages that you're sending, or trying to look at what all websites you visit, or try to capture your network traffic. I can do anything. Anything is possible once you're into my network. So that's one point. And then WPS attacks. So now WPS is nothing but what happened is, to remember a Wi-Fi password, it was complicated because I can have any symbols or I can have any alphabetical orders and sequences put into it. For making an easy access for the users to connect to the Wi-Fi, they came up with something called as Wi-Fi protected setup, which is WPS. nothing but an 8-bit character pin which you can use for logging into the Wi-Fi, which is configured for you to be logging in. Now, I as an attacker, since it's only an 8-character long pin which is generated, I can easily brute force those 8-bit characters which is there for the network. Now, using a dictionary method or using a brute force method, I can just brute force that and log into their network. So that is one of the way of me attacking it. Now, which was actually built for easy access for the users to log in, but unfortunately, it was also an easy way for an attacker to get into the network. Coming to the next section, which is WPA or WPA2 cracking, which is nothing but the same thing, Wi-Fi protected access. So it's like trying to connect to your Wi-Fi. What happens is initially when you try to connect to a Wi-Fi, you need to go through some shaking hands by the router and your computer. Now, you might have heard of a three-way handshake while you're learning about TCP/IP, where the server and the client is going to be having a three-way handshake between each other to confirm that yes, they have connected to the network and all those things. Same thing happens with a WPA, but where we have four-way handshakes between the client, router, and the system. What is exactly trying to connect, which is the client. Now, between the client and the router or the access point that you're trying to connect to. So there's a four-way handshake that happens in that. Mixed Kitty looks at Glitch and asks, "What kind of attack are you thinking of demonstrating, Glitch?" Glitch peeks back and forth before coming to a sudden stop and says, "Today I will be showing you how the WPA and WPA2 cracking attack works." So WPA and WPA cracking. Now, before I just give you a brief about the four-way handshake. What exactly happens in that four-way handshake? So what happens is I'll be a client. They have given you a description. I will use that four pointers to describe my points. Now, I as an attacker will be exploiting these two-way handshake by this fundamental concept of networks talking to each other. Now, a router is going to send you, when you connect to the network or try to connect to a network, what happens is a router wants to identify that you have a password to it. Now, it's not directly going to ask you a password, but whereas it's going to ask you to solve a challenge for you. Now, this challenge will be in the form of some way to say asking the client, telling that, tell me that you have the password without telling that you have the password. So something like that. It's going to give you a challenge, telling you to encrypt something with the password key or something like that. Now that's going to happen in the first step. The router is going to be sending that to the client. So let's consider my client system to be here. So the client is going to get this challenge. Now with this challenge, it's going to use the password with whatever it has. It's going to create a packet, and then it's going to send this packet back to the router again. So now it's going to send to the router. It's going to be responding that back to the router. Now the router is going to look at that request, whatever is sent, and then it's going to analyze it, break it down, because whatever is sent from this packet is only be read by the router and it cannot be read by any other devices. So router knows a way how it can decrypt whatever is sent by the client, and then it's going to decrypt it, and as a part of confirmation of uh, having that authentication done, it's going to send another response to the client saying that yes, you can now communicate to us and all those things, and the final check is going to happen between all of them. So I know it was very brief. I wanted to keep it very brief because the description is already given there. Now, this handshake exactly does not share you the password. It's not going to be in a clean format, whereas it's going to be in an encrypted format while the client is sending to the router. Now, I as an attacker wants to capture this timing of the router and the client exchanging this sensitive information like the password. So I need to capture this instance, this four-way handshake, so that the encrypted method or encrypted password, what is that, I can later then take it and then brute force it or use some dictionary attack to then later crack it offline. So that's what we are going to be performing today also. So the vulnerability what lies is that the four-way handshake listening by any devices can be capturing this four-way handshake if I'm into the network, and then I can decrypt it later. So in practical, we'll be doing this. For that, they have told us to open up a terminal. I guess we need to connect to their SSH session before we actually perform this. So let's open up the terminal here and give it a minute for it to load completely, and go up here and click on start machine. I guess I should have done it earlier so that by this time you would have got the IP address. But yeah, let's copy the username here, and then let's say glitch. Okay, so we got our IP address. So let's put that into our terminal here. I'll say 10.10.161.225 and then press enter. Now it's going to be asking me for the password. Glitch. Oh yeah, I forgot to specify SSH. So SSH glitch at 10.10.161.225 and press enter. So it's going to confirm me to say, are you sure you want to continue? So I'll press enter. And now I'm going to specify the password of the user glitch. So it's password 321. And now we are logged in as glitch. So let's clear the terminal here. I'm going to keep my terminal here side by side to the description of TryHackMe so that we can have an easy look at the commands and dive in with the continuity of the story. So first, let's run the command iw space dev. So this is a command which is going to give us a description about what are all the interfaces that we have. Usually here we'll have a wireless access point or the NIC card, what is there in your system. It's going to be the description of that. Here it says it's a physical device and it is called as WLAN2. So wire LAN 2, wireless LAN 2 is the full form of this. Now here we can see the address, which is our MAC address of the system, and the type what we're using is managed. So there are two types of interface cards which we can have, or the way how we are going to be talking with the wireless medium is there are two ways. So one is the managed way and another one is the monitor way. The monitor way will come back later from your description itself. So we have the MAC address and the type that we're using now. Now what we'll do is, now let's scan for any of the nearby Wi-Fi access points which we have. So what we'll do is we'll run the command sudo iw and then say dev. Let's say WLAN, which is our interface name. So WLAN2. Let me spell that right. So WLAN2 and then say scan. So this is going to scan for all the wireless network and access points that is nearby present to this device. So let's give it a minute. If everything goes right, we'll have this output in our screen. So now what are the important points that we need to see here is, I hope I will just reduce the size of the terminal here. Now it says BSS. So BSS is nothing but the name of the router or the wireless access point which is present. It's the MAC address of that access point. So that is the BSS. And then we can come down to see for some other things like the SSID. SSID is the malware. What is the name of that Wi-Fi name? So we can see that there. And then comes let's go to the description here and look at what all they have given us. They've told about the RNS. So RNS is a robust security network. What kind of network is this running? So we see RNS. It says version 1, which usually means that it is running a WRSN is basically, it's as soon as you're going to see that, it's like you're running a WPA2 version of network security for that Wi-Fi. There are right now the standard industry practice is to use WPA3, which is for all the systems if you're working in an industry. But usually, RNS is the protocol used by WPA2 version of network security, and we also see that it's running a version 1. And then group cipher and pairwise cipher is being used of CCNP. They have given us. The name of it is counter mode with cipher blockchain message authentication code protocol. So it's basically an encryption method used by an WPA2 wireless access point. Now, authentication suite uses PSK, which is password pre-shared key, which is nothing but the password which is given by the client or by the router. And other points that we would like to look at would be the DS parameter set channel, and that is like basically like the channel or the frequency that the router is capable of communicating with the client. So it's that location or that particular frequency that we would like to communicate with the router. What is available to us? So that's what is given here, channel 6. Now, right now, with two versions that is present everywhere in the home and the industry, is for 2.4 gigahertz and 5 gigahertz of wavelengths and frequency that we use. So what we do, what happens with 2.4 gigahertz of frequency is that we are using channel 1, 3 and 6. I guess the description is here. We're using channel 1, 6 and 11 for communicating between the Wi-Fi's, just so that we don't overlap with another Wi-Fi which is present in the same range, and then we are going to be losing our packets and all those things. So we use 1, 6 and 11, and for 5 gigahertz we are going to be using much more than what is defined for 2.4 gigahertz of range or the band which is there. So here it's using channel 6, which means that we're using 2.4 gigahertz of Wi-Fi signal strength here. Now we would like to change, now that we know what is our access point, what is the BSS ID and all those things. Now let's go for the way how we're going to be attacking. So now we want to perform a scan on this. For performing a scan against the target or the Wi-Fi access point what we have, we need to set our option from managed, which is to act as a client to connect into a Wi-Fi. We will get into an option of doing a monitor, or we'll be performing looking at what exactly is happening in that access point. For that, let's use this command which is given here. I'll say sudo ip link set dev wlan 2 down, which is going to turn off my interface. So since I'm using sudo, I need to specify my password, which is password 321, and says sorry glitch, you're not allowed to execute wlan as a root. Okay, is that the expected behavior here? I don't know. So this is to turn off the device. Let me try this again without the sudo privileges. So ip link set dev wlan 2 down. So it's a garbage. Okay, why is that saying that? Okay, dev. Okay, I misspelled that. So dev down down operation not permitted, which means I need sudo itself, and it says yeah, it ran. So it was sudo not link, sudo ip link, right? Yeah, that's what the command was run. I don't know what exactly happened here, but yeah, sudo works. So now we have turned down our interface, which was trying to scan for all the networks. Now what we'll do is now we will set the type from manage to monitor. For that, we'll use the command sudo iw dev and then wlan to set type monitor. So now it's going to be setting up uh, no such thing. Okay, wlan. Okay, now it has set up my Wi-Fi interface from manage to monitor, which has the ability to now look for the activities that is happening in the access point which I specified. So now I need to bring this up. So I'll say sudo ip link set dev wlan 2 and then up. Now it has brought up my IP or that network interface card for the Wi-Fi to be accessed. Okay. So now after that, let's look for another information about what will be the changes. So now let's look at the information about our Wi-Fi interface. So let's run the command sudo iw dev wlan 2 and then dev wlan 2 and then info. Okay, so now this is going to give the description about the wlan 2 interface. It says type monitor, and this is wdev and all those things, address and all those things are there. So we have a monitor type now. So now let's perform an airdrop attack, which is going to now look at the possible Wi-Fi access points which are present, and using its BSSID and SSID, we're going to be monitoring all the activities that is going to be happening in that network. For that, let's run this command which says sudo airdo dump -ng and then wlan 2. Okay, by running this command, we can see that it has given us the nearby Wi-Fi accesses which are present, which is malware MP, malware M underscore AP. So it's an access point of malware. So we have got this SSID. Now what we'll do is let's scroll down here and then let's click on Control C, which would kill this process. And now let's run the following command, which says sudo airo dump -ng and then -c is going to be specifying which channel we want to be running. Now here they have specified what channel the Wi-Fi or the access point is running. So we'll say 6 and then -BSSID. We need to say what is the BSSID of the router or the access point we are trying to connect. So let's copy this and then paste it here, and also add an extra 0 because I left it out. And then let's say I write this output, whatever we are going to be performing or whatever you see or capture, put that in an output file. So I'll say output -file, and then I need to specify the interface that I need to be using. So I'll say WLAN 2 and press enter. So now it's going to perform a scanning in this network to look for any of the users or any of the access points or the clients which are present in this network. So now we have got an output after waiting for some few seconds. So we have got a BSS ID and the station ID of the user who is present in this network. So this person has already been in the network or has already been authenticated in the network, and we see that their BSS ID and session ID is printed out to us. Now what we'll do is we'll open up another terminal here side by side. Here we will perform an action to de-authenticate my victim here who is present in the system or in the network. Let's open this. Okay, from here I'll open this another terminal. Now I will log in the same credentials to the glitch. So my main motive now is to de-authenticate this victim what is present in the system, and then to force them to reconnect to the network, so that when they're trying to reconnect, they're going to perform that four-way handshake once again. So with that four handshake being done once again, I'm going to capture that handshake, the entire handshake, and also that encrypted messages what they're transferring to each other, and then I'm going to locally crack them up. For that, let me connect with another SSH session to the glitch. So I'll say SSH glitch and then my target IP address and then my IP address that I need to connect to. So let me scroll up and then paste that IP address. So it's 10.10.161.225 and press enter and specify the password to be password 321. So I'm logged in as glitch. Now let's continue with the sort of plans that we thought we will do now. For that, I'll scroll down back again for the commands. So now we'll run this command, which is sudo air reply. So reply -ng and then specified with O and specified with 0, which indicates that we're using a deauthentication attack for our victim, whatever is present in the network. And number of packets that I want to send for deauthentication, which is going to be 1. And then what is the access point. The what is the BSS ID of the access point which I want to try to de-authenticate into, which I want to try to de-authenticate the clients which are present in that network. So let me copy this PSS ID of my access point. So let's copy that and then open this again. What happened to the other terminal? So yeah, let's open this and then paste this in here. And then I need to specify my client's PSS ID. So I say -c whom I want to de-authenticate from the network. And I will copy their station ID, which is their MAC address. So let's copy that. And then come here with opening this terminal and then pasting that MAC address. Now I want to say what interface I want to send this de-authentication packet from. Because I have WLAN2 set to monitor mode, I'm going to say WLAN2 and then press enter. So it's going to be asking me for the password of glitch, which I will specify. Okay, I have done a mistake with the command's name. So it's air replay, so not reply. So it's air replay -ng, then press enter. So now it is waiting for the beacon frame and it has sent that dump to the client, whatever I have asked for. So now you can see that they have given us. Now you can see that we have got in our notes section saying that EAPOL, which means that the client has tried to connect back to the network. That means this has also captured the four-way handshakes of it. Now let's kill this session, or let's go to the another terminal itself. What is here, and then let's try to crack whatever handshake they have done with the session. Now let's try to crack the encrypted messages, whatever they did, or the handshake which the client and the router did. For that, we'll be using a miniature version of rocku.txt, which is present under the Glitz home folder. So we have the rocku.txt. Let's use the command sudo air crack and then -ng crack -ng, then A2, which is going to be saying that we're using attack mode of tracking in for the password. And then let's say what is my BSS ID which I need to be connecting into. So we already have our BSS ID of the router or the access point. So let's paste that in here. And then what is the file that I need to be using for, or the word list which I need to be using for cracking it. So I'll say home, then glitch, then say rocky.txt, and whatever output I'm going to get, which is going to be the .pcap. So we see output, and then I'm going to specify star whatever .pcap. So cap, not pcap. Pcap is for Wireshark stuff. So we say cap, and then I'm going to press enter. Now it's going to try for all the possible ways to crack into this Wi-Fi using those passwords which is there, and then it has already cracked for the password. So this is the password what we will get once the Wi-Fi is cracked. Now if the password strength is really weak, you will get it in such a easy time frame. If not, it'll take few hours to crack the password. Now we usually don't use Rocky. We have other lists from GitHub and all those places to get the password. So now that we have already got the password, let's kill this session and try to log into that Wi-Fi signal again. So let's open this terminal because I already have the password there. And then let's run the command WPA underscore passphrase and the SSID. So malware m underscore AP, and then I will paste the password that I found. So let's copy that and paste it in here. and say yes. So we have got an output of the passphrase which we'll use now. So I'll say sudo. What happened to my terminal? I'll make it come up. Yeah, sudo wpa underscore supplicant. I don't know what that command is for. So supplicant hyphen b hyphen c config I wlan 2. So it says you will also notice that WPA supplicant has automatically switched our WLAN 2 interface to managed mode. Okay, so let's press enter. So successfully initialized WPA supplicant. Uh, so no such file or directory is present. Why is that? Oh, we forgot to save the above output to the config file. So let's say config that has saved it, and now yes, cannot get information. Okay, I can ignore that message. So now let's try to run the command iw-def, so which is going to give us the information about the interface that we are working with. So we see that we have connected back to the managed network. From monitor, we are back to managed, and we are connected to the interface. Okay. So now let's move to the challenge of today or the questions of today. What is the BSS ID of our wireless interface? So this is our wireless interface. So let me copy this. Come here to the clipboard and then copy these contents and then paste it here. So that is our MAC address basically. And then what is the SSID and the BSSID of the access point? Okay, so let's go back to this terminal. Let's close this and go back to the terminal where we had the BSSID and the SSID. So let's first copy the SSID. I guess the terminal view is little small, so I'll make it little more small. This has fully not shown to us. That's okay. We already have this information here. So let's copy this. That is the SSID uh, of access point. So let's say SSID, comma, and then the BSSID. So the MAC address of our access point. So let's copy that and then paste it in here. Okay. What is the BSSID of the wireless interface that is already connected to the access point? Yeah, so that is our victim's BSSID. So let's copy this. Come back here, copy it from the clipboard, and then directly paste it in here. Oh no, BSSID. Okay, close. So this is the BSSID. This is the MAC address of my client. Can you please move that away? Yeah. So this is the MAC address of my client. So let's copy that and then paste it in here. Press enter. That should be it. Yes. What is the PKS or the password found after performing the crack? Okay, so let's open this terminal here and then using the password that we got here, let's copy this and then paste it in here. So yes, now if you did enjoy this task, feel free to check out the networking module. Okay, so let's click on complete. With that, we have completed the day 11 of Advent of Cyber about wireless cracking or Wi-Fi cracking and Wi-Fi attacks. So that is it for this video. Hope you did enjoy and learn something new out of this video. If you did, please hit on that like button. And if you're new to this channel, hit on that subscribe button. And stay tuned in for tomorrow for the day 12 of Advent of Cyber 2024 of TryHackMe. Continuing this series, I'm excited for the day 12 of Advent of Cyber. So till then, stay happy, stay hacking, stay smiling. Bye bye.